I will forget this. All right. Hello, everyone. Here we are, week 3 of Introduction to Statistics. In our first week, we learned about the types of data. In our second week, we learned about categorical data analysis using the Titanic data set. And this week, we're doing numerical data analysis. And notice that we use the language of missions, because that's, in essence, what you're doing when you're a statistician. You're actually kind of like Sherlock Holmes. You are, I guess, you have an assignment, you have a mission. And sometimes there's not always one correct answer. And sometimes we're not certain about what is actually going on because there are many different interpretations. And what I like about, what I hope you like about the course is that for each mission, not only are we exploring a different concept and a different method and analysis, but we're also kind of taking on a different role, because there are the different ways of using statistics. So last week we took on the role of historians, quantitative historians, and looking at a case study, really, a very particular event, and tried to and learned about this using categorical data analysis. This week we're using numerical data analysis as psychometricians. Now, psychometrics is what you can actually probably divine from the word, right? Psychology, metrics meaning measurements. And psychology is really interested in developing and creating, through questions, through surveys, measurements of concepts or constructs that we don't actually observe. So if you want to know if someone is depressed, for instance, you could understand their brain. Now, that's not practical, because statistics is an applied science. It's not practical in a clinical setting, at least not now. It's often easier to have people ask a series of questions. We call these inventories, like 20 questions might be submitted. Or often, sometimes it's the psychiatrist or the doctor. And psychometricians are in the business of doing this. And we're taking on the role of a school psychologist who actually did an academic study of popularity. What do kids think makes them popular? And in our analysis of numerical data, we're actually learning a different set of concepts. So this is where we get to our 2 core readings. And I'm going to share the screen just as a reminder. If you haven't taken a look at the readings, please do. There we are. You see them in 2 tabs, right? You have basically one, which is the student's guide to R, which is much shorter. And this is the R code that we use each week, which is why we have you install this package, this library of commands called the Mosaic package. And the companion book is the Student's Guide to R. I love it because it's free. You don't have to pay $200. And it's also pretty clear about what the commands do and what they don't do. Now, they have a particular example. So if you want to explore the analyses further and really understand it, and you're kind of a hands-on learner like me, then I encourage you to explore and use some of these commands here. And that's what we're going to do for one part of the week. For the first section each week. Now, the much longer book includes problem sets and includes more detailed concepts and elaborate explanations of what we cover in class, which are, this week is numerical data analysis. Some of this goes beyond the course, but I know many students who have felt like when they're studying for the midterm or studying for the final exam, they feel like okay, we want more problems to look at. We want more examples. And that's why I encourage you to look at these two. That's why I also include these two. In addition, of course, check out the R tutorials page, because if you want to review the problem sets, look at the R tutorials page, because each week there's an R tutorials under the R tutorials page. There's a review of the questions in each mission conceptually after it's been posted. And then there's also, before the assignment is due, I post a detailed review of the code we provide. And that's pretty clear. Now, you can check that out. You can check that out now. But that doesn't necessarily get you to know or understand aspects of the class material beyond the missions. So that's what I want to provide here. And of course, address any other questions that arise. So we can sort of think of this as having two sides, conceptual and analytic. And the analytic part is a student's guide to R. The conceptual, of course, is the open intro to statistics, which can be a little difficult to say every once in a while. Before we get to this, and I'm sure some of you might have heard that spiel before, if you attended the first section. Do you have any questions about navigating the Canvas page and finding the relevant information? I just want to be sure that everyone is seeing everything and everyone is kind of familiar with the material available to you. I mean, that's half of the battle is knowing where to look. Okay. Oh, good. Thank you. I appreciate that. Someone just said there it's pretty user friendly. Thank you. We really tried hard to make it relatively simple, but it isn't necessarily the case that we've gotten a lot of feedback. I'm going to say one thing for those of you who haven't asked a question, but it is relevant to many of the international students. We use YouTube as a companion sort of a video platform. And I mentioned this in the announcements, but it's worth repeating. We use YouTube because it includes playlists that will automatically process. We also use YouTube because you can watch it on your smartphone. And we are all very busy. I know many of you have many different roles and obligations, and we want to be sensitive to that. And I know some of these sections and videos are quite long, so you can break it up. You can go from one section to another, and you can watch it while you're walking or while you have a few minutes or while you're commuting. I think it's more accessible. Also, not everyone knows this actually. You can play it at double or triple, or double the speed. In addition, for most of the videos, you can also right-click on the lower right-hand corner and actually see the transcripts. It's not perfect, but they'll have timestamps. So if you don't want to even do that and even watch the video, you can actually just read the transcript of what I'm saying. It's not perfect, but it's pretty good. And that's the reason we do it. Otherwise, you might have to sit for 2 hours. Okay. Last thing, for those of you who are international students and you don't have access to YouTube, please let us know. I know there are other video platforms. VPN clients tend to work, but I know that's often less and less accessible. But it's what we do. It's also why I embed everything. I embed them in the announcements. I also embed them in, wherever else, in the R tutorials page. I apologize. I'm looking for, as I'm talking to you, I'm also trying to find my copy of the syllabus, which is something I do. I always print it out. Here we are. Okay. I encourage you to print everything out. I print out the book. You can also order the book online because studies show that learning, either if you're writing it down or if you're reading and highlighting, it's going to be a lot easier for you. So I would print out those slides if you can. So let's go to the course readings for this week. Yeah. You know what? I'm just going to navigate to the course webpage. I'm sorry for that. All right. So for this week, we have basically, I don't know, about 10 pages of chapter 1 for Open Intro to Stats and about 10 pages for Student's Guide to R. Now, the way I think about things is I think of concepts and methods and tools as basically being interchangeable. So when we think about numerical data, it's distinct from categorical data in this fundamental sense. Categories, there's no, how do I put it? There's no distance between the categories that are meaningful. Male or female. What is the difference between male and female? If we assign females the number 1 and males the number 2, there's no meaning to that. And in fact, you might see some older textbooks, and those often, they'll call that qualitative data analysis. When they first started studying or creating statistical models of categorical data. In the R programming environments, you'll learn that this is often called a factor variable. That there's a sort of a technical history there, but think of it as like, well, what are the reasons I don't want to go to the store? Well, factor 1 is this, factor 2 is this. Those aren't numerically distinct. But numerical, the distances between the values matter, right? If you are age 20, then you are half as old as age 40. That's a relatively simple example. So if we go to the Student's Guide to R first, and we may open up R, but I actually want to encourage you to actually think about R and programming without always having to open it up, because I know it's not always accessible. And I know some of you have had issues this first week. If we look at that, then we'll see some of the code here. Hold on for a second. I seem to have issues. Can you see the actual Student's Guide to R page here? We should go to page 27. Okay, here we are. Part of the reason I'm not opening R for a second is keep this in mind. Thank you. Thank you, Fatima. Thank you, Andrea. Is that when you are taking the exam, you don't need to use R. You can, but we are not we don't expect you to be computer programmers. What we want you to do is to be comfortable looking at statistical output, what we often call raw statistical output, reams of data. And you're going to look at that, and then you're going to translate that. So the reason we include R is that it is free, of course. It's very common. Google uses it. Many very powerful organizations use it. Academics use it. But the real key point here is to interpret and understand what the output looks like and what it means. Otherwise, it's just a copy and paste job. And we're not computer programmers, we're statisticians. Okay, so keep in mind this chapter that we're focusing on talks about one quantitative variable. The reason we're talking about it this way is that that's the essence of quantitative analysis, is starting off with one variable. And the way you should think about numerical summaries is that it is actually the first kind of data that became available when we started developing the science of statistics. We actually had a lot more numerical data available as a society than we did qualitative or categorical data available. And this is precisely because a lot of statistics came out of the church, and then it moved to the state. And these are called vital statistics. If you go to the US, the federal government of the United States website, you'll see they'll still have a department called vital statistics. That means life and death statistics. So the churches would categorize or count, longevity, and they'd count the number of souls that were saved and things like that. And the Catholic Church would keep very meticulous records of these. And then as nations became more, governments became more secular in Europe, and as we became more industrialized, businesses wanted to count profits and count money. So numerical analysis actually came before, and it became much more prevalent and more problematic, because we had to take all what has been called an avalanche of data, and we had to summarize it. So think about this first part, numerical summaries. When we're talking about numerical data, our biggest challenge is reducing the complexity. And we do that in two primary ways. First, we look at a measure of central tendency. Or, in other words, where does most of the, let's, for example, if we look at ages, the distribution of ages. Actually, I'm going to use a different example because it fits a nice kind of a bell-shaped curve. Height. If we look at the height of people, so the height of males in the Netherlands, it's a country with the tallest population on average. We would want to say, we'd want to somehow figure out how to summarize that. Well, we do that if we want to summarize the height of Dutch men in any given year. We take all the data, all these numbers, and then we're going to give one measure of central tendency, which is what is the most common, or what is kind of what is it on average? What's the middle part like? And then the measure of spread or distance from that central tendency, right? So we have some measures of central tendency and spread. Here you see some of the codes here for R. You can actually copy and paste this and do that. And you're going to use a data set on depression, right? In this week on psychometrics, if I talked about answering 20 questions. Well, you can add up those questions, and then you have a score from 1 to 20. That's actually the CESD. And It's a pretty common diagnostic method for depression. Now, you'll see that some of this code here, but in the example data set they use is an intervention for improving the lives of homeless individuals. And here they're going to look at the depression of the, the average depression level of participants in the sample. Now, they talk about some other things about lattice graphics and this kind of junk here. But the main point that we want to talk about here is that when we think about central tendency, most often we're talking about the average. It's the most common measure of central tendency, the mean, which is just simply the technical term, but it's actually just the average. And what we want to talk about when we look at the code here is they're going to talk about this being similar to a linear model. It's not that important, but what I do want to emphasize here is when you're typing in the console, and this is the code, you have a kind of a similar logic. You'll see these right here. These are in the code available for each week that we already give you. Right? This is the package. You can use library or require. All we're saying is once you've installed Mosaic, now we want to open it up and use it. You also want to use the data available that comes with the Mosaic package. One thing we don't talk about in the class is, if you notice in previous sections, and you look at the output in the modules, the default for R is to give us something like seven digits, right? So you'll see things that are quite wild. Well, there's a nice little function here called options that basically reduces the number of digits in any decimal or any number to 3. So if you have the number 333, it'll include 333. If you include but if you have decimal points, like if you have 333.001, I believe it only rounds to the whole number. So it includes as many numbers or spaces as you want. That's useful. I don't think it rounds. It just kind of makes interpretation a little bit easier. So it's not a rounding function. Now, you're going to see this more often, and you want to remember this little function in bold. If you want the average of something, you're going to type mean, and then you're going to do something else. Now, before we continue, what is a function? Well, it's R lingo, and R is full of lingo. I actually think it's a form of esotericism or gatekeeping. It's kind of intimidating to hear these things. Oh, did you vectorize your data frame, or did you use a string function? That's just jargon. Don't worry about it, okay? If people are using more complex language than necessary, sometimes it's to be more efficient amongst themselves, but other times it might be a kind of a form of gatekeeping, I personally think. And that's why I like Mosaic, because Mosaic really tries to implement a language and syntax. And by syntax, I mean this stuff here, the code, the stuff you write. It implements a kind of syntax that is more accessible. I've decided that we're actually going to use R. So I'm going to show us R. Precisely because I want to really show you how easy it is to, whoops, I think I shared this whole screen and I just wanted to share RStudio. Not that I would mind, it's a little simpler. Do you see RStudio here? I don't think I see. Oh, here it is. Okay, good. So here we see our similar RStudio panes, right? Here I have a workspace. Here I have all this. Blah blah blah. It's empty. What we do want to do is look at packages. Now remember, if you look at the installation packages, it'll do an autocomplete. I can press tab here, it'll finish it. A nice little window pops open. Hold on, someone has a question or comment. Okay, thank you. Thank you for the verification. Now we have the cursor here. What I want to remind you is that there's this little caret here. This little caret here is actually where you're supposed to type. So if you want to work interactively and you want to type things and tell your computer what to do it here. But keep in mind, we first have to install our packages. Sorry, we don't have to install, because remember, once you install them, then you just have to load them. And loading packages and installing packages are two different things. Installing packages says, I want to save this on my computer. It's like going to the bookstore and buying a book. Loading a package or using the library function means you're going to, once you've bought that book, you're going to take it off the shelf, and now you decided to read it. And that's what you're telling the computer to do. Now I want to show you something. Like many things in R, there are many different ways to do things. I'm not going to install the package because it's already installed, and yours should be installed already. So I interrupted myself, but I want to clarify this. Like many things in R, there are many ways to do things. Now that's a blessing and a curse. For example, if you look at the code they have the require function. I could require Mosaic. It even tells us that, and it says press F1 for additional help. These pop-up windows, it's kind of nice. It helps you out. That will do the trick, but also will the library function. Right, same thing. Not sure why, just it's one of those things. But there's also another way within RStudio. If you're not comfortable typing things out, look at this right here. There's a packages tab. We have the plots tab open because remember, when you're looking and creating outputs, there are two sources. There's the console right here, kind of like Star Trek, right? There's a console or a bridge, I don't know. Sorry, I'm not that big of a Star Trek fan, but you know, there's a place where you actually do the work, but then there's a place where you actually view the outputs. And the console provides commands, and the commands always have the blinking cursor. It's waiting, 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 with that little chevron. This is a little chevron right here. All that says is, okay, that's a line where you can type whatever, you know. You can do print, which is hello world. Right, if you're a programmer, you know it. That's quite a famous little code. You can do that. You can also do other things. You can add numbers, and you can do things like that. And I show all of those in the R tutorials playlist. I take you from installation to using it as a fancy calculator, which can be useful. Now, I like to clear my console. I don't like to see too much stuff. So I'm going to do a keyboard shortcut on my Mac. I'm going to do, I press Control and I press L. And now it just clears it. Doesn't do anything else. It's like an Etch-a-Sketch. It sort of shakes things up. I don't like to see too much junk. Now, I'm reminding you where to look for the output, because remember, this is not a computer science class, it's a stats class. We want to interpret outputs, and we want to interpret plots or graphics. And you're going to find that in the console in a different color without the chevron, but right next to the code, right next to the chevron. You're also going to see it in the plots pane with these little arrows here. That's all I want to say. Now, unlike our problem sets, because we're going to install the Mosaic package and the installed data for Mosaic, we don't have to actually install any packages. Look at this. So, what is that? That's hilarious. I use a Mac and I speak French, and I believe my Mac quite literally thought I said something en in French, so I apologize. So I'm going to turn off my dictation for that. That was, it's always a little terrifying when your machines are listening to you. I'm not even sure how I could have said that. Okay. Anyway, things happen. Okay. I'm going to move the share now to back to our Student's Guide to R. And I want to take you back to this right here. This is what your screen will look like. Ideally, you can copy and paste this, and you can just put it into RStudio, and it will evaluate the code and give you this output, which is the average depression score. It looks like they might have a different scale. Maybe it's 1 to 50. But the higher the score is, the more likely you are to be depressed. So this is an easy example or clear example of using a built-in data set that we don't have to download or anything, but that comes with the package. And most well-developed packages include built-in data sets. And we'll talk about that later when we think more about the final project, because there are a multitude of data sets built within R. Now, there are several reasons R includes built-in data sets, but the most obvious reason is that most statisticians do learn through getting their hands dirty, so to speak, through working their way through things. And so each package you'll look at often will include ancillary data sets that you won't see, you won't find them anywhere except where the package is kind of cached away or hidden away when you installed the package. So I'm going to take this right here. Actually, you know what I'm going to do? I'm going to move to a full screen, as long as it doesn't look too chaotic. And we're going to put these side by side, and I'm going to show you how to interface between R code and then the syntax. And this is for those of you who want to get your hands dirty and learn interactively using the resources here. So I'm going to get us to full screen as soon as I arrange things. I'm just changing this. Okay, this will be a little bit smaller, but that's okay. Okay, stop share, and I'll do a new share. I'll share the full screen. There we go. We'll show the desktop. Okay. You should be able to see me here. Tell me if you see like a little message bar or command bar. I'll try to get that out of the way because I have that on my end. So you should see at the bottom of the screen RStudio, and you should also see within view a little truncated version of our page here. But before we get here, remember we want to load. Okay, thank you. I appreciate those of you who are confirming what you're saying, because I want to make sure that you're able to learn. Okay, so here we have the console. Here we have the environment, which is just our sandbox, is where we keep everything. History, this is everything that I've typed in so far. Some of it's from last week. But you see the commands I typed here. I rarely look at that, but everyone has a different style. We know how to install packages, and we know how to load packages using these commands here. I want to show you something else. There's this packages thing here. You can also load packages by looking at what you have here. These are packages that are installed. This is my library. So you might see some things that you also have. You might see some things that you may not have. Now it's in alphabetical order, so we can go to the M, and here we see Mosaic, something called Mosaic Core, and Mosaic Data. If you click on this, it'll have that description here. Look at all these sub-commands, all these subroutines. You can do that, but we're going to keep it simple. We're going to press that back arrow. And if in doubt, just go home. Oh, I already went to the help part. I have a tutorial on help. Please look at that on the R tutorials page. But what I'm going to show you is how to install packages without ever typing code. This loading. It's already installed because it's here. It's on your machine. We're going to load it by just clicking this. Now you'll see a lot of red. That seems a little scary. Sometimes you want to see whether these dependencies are here. Notice it says loading required package. And it looks like all of that worked. Some students had issues loading other packages. This thing called YAML. That's probably because they had the newest version or something like that. Now you'll notice this is a little more complicated, right? This is a little bit longer. But the nice thing is, when you click on this, notice when I clicked on just Mosaic, it automatically installed or loaded the Mosaic data package. It kind of assumes if you're loading a package, you might want to use the data. You can do Mosaic Core, but it's not necessary. Now, we do library Mosaic. They do require. They do the same thing. I'm going to unclick this, which is actually going to detach it, which means we just put our book right back on the shelf. Unload equal true. It's not that important, but we can also do that here. So it's a good way to learn different kind of functions. These are called functions because it's a command, it's an order, and in the parentheses, there's some details about the specifics of it. I want to do that because then I want to take us back to, I'm going to press carriage return a few times just so we have some space here. I pressed up and then I'll actually get you through the history, but I want to get a little space here. And I'm going to type, actually I'm going to do Command L. I like this a lot more. I'm going to type what they have here, require Mosaic. Look what just happened to the right. We see the check boxes there. Require, and the other thing are the same. And we also see the data there. They're a little redundant. If you notice, if you want to write to the authors, you can say, well, you don't need to have that. Okay, I'm going to clear the screen one more time. Just so you can see it at the top, I'm going to do this options function. And all we're doing is we're going to say, I don't want to see 1,000 digits. I just want to see 3. Okay, that didn't do anything. Well, let's take a look now. We're going to do the mean of this. Now, I want to emphasize something. Remember, we have the Mosaic data here. And if you want to know more about the help RCT, it's the help randomized control trial. It's an experiment. It's an intervention. If you want to learn more about this data sets, look at the appendix to this Student's Guide to R. For a couple reasons. First, you'll know more about the context. Statistics is not just numbers, it's the context, it's the situation. You have to know what the data mean to interpret them. The second thing is they use this data set throughout every example, so it can be kind of repetitive. But the nice thing is we can do the mean here, and guess what? It looks exactly like what we see there. Now I'm going to show you this now. From now on, when you're going through the Student's Guide to R, and you're say, you want to learn more, do this. Copy, even paste, and I'm just going to hazard this. I don't think it'll work. Yeah, it'll make those errors. So we're going to do a new script here. I'm going to copy and paste here what I just have here. Keep in mind when it has a little chevron or the caret, that's code. when it has this little number in a box in these brackets, that's output typically, or whatever is printed out. And you notice it's a different kind of what they call fixed format font. It's a different font. But we want to get rid of this. And it's a little slow, but c'est la vie. But that's very easy. Okay, we don't have anything installed. We have nothing here. Now, we also notice, I wanted to show you one other thing, and this is important when you're doing the final project. See this red here, and it has a little asterisk? It's Untitled 1. That's a warning sign. It's saying you haven't saved your script. You're going to lose it. It's like not saving your Word file. So I'm going to do Command S on my Mac, and I'm going to save it. I'll save it to the desktop. This is going to be called Students Guide to R, and I'll do it lowercase actually. Students Guide to R. I'll do that, and we'll save that to the desktop. Remember, it's a .r file, capital R. It's a script. It's our recipe. Now, also remember from last week, if I press Shift, the number 3, I have a little hashtag here. It's the color green on my machine. These are comments. I can say whatever I want, and it doesn't matter. These are like notes. These are like marginalia if you're reading a book. So there's a bit of information here, right? You have these numbers here. These are the lines of the code. I can press a carriage return. Spaces really mean nothing. These green things are for you. It's reference, right? You want to know what you're doing. Well, I'm going to say, this is a mission to categorical, numeric data example. And I'm going to do Command S because look, it's red. If you look at this little corner right here, it's red again. I'm going to save it. And here we are. We're going to run and evaluate this. Now I highlight all of it, and I'm going to click this little run button. And now we can see what just happened. It has all the red here that tells us that we did everything. We see that the packages are installed because they've been clicked. And that's all you have to do. And that's the nice thing about this. This is why we sometimes like to have pre-installed data sets, because it helps us learn what's going on. And you can fiddle around with things now. I'm going to do Command Control L again, just to see what happens if I change these digits to, say, I don't know, 6 rather. And I'll run it again. There you are. So that's a useful command. I often say commands because a lot of major stat packages like Stata, SPSS, and SAS will call these commands. But what we're basically showing here is, okay, our first measure of central tendency in R is the mean, and there's this weird little tilde function that's called a tilde. Don't worry about that so much. We'll talk about that later. They're making this a little bit too much information, but if you're interested, they call this the formula notation. The idea is really whatever's at the left side of the function is what you're doing. I'm sorry. Yeah, whatever is on the left side is the result of whatever you want to put on the right side. That's kind of what it is. It's akin, they call it like a formula for notation because they kind of want you to think of it as an equal sign. And I don't want to say that too much because you'll notice we do have equal signs here. Well, it's programming language. We can't use an equal sign all the time. It's actually more directional. What it's really saying is this junk here, these arguments are, which is what the tilde says, going to be transformed into a mean that will print out in the console. And that's what a formula is. Think of what a formula means, right? If you're a chemist, you might create a formula. There's an old song, Love Potion number 9. whatever ingredients were in that formula, it was the 9th one, maybe it has 9 ingredients. You mixed a bunch of stuff in there, and then you did something to it, and then you have the results. That's what that little tilde function is, and that's the formula notation. For those of you who are having issues with connections, I totally understand. Someone had just mentioned this to me. No need to apologize. It's technology. All of this will be posted as soon as possible. You know, if that's an issue, I understand. Now, there are some other things here that you can kind of invert the expression here. You can cut and paste this yourself. All it's saying is that, okay, well, you don't have to type it this way. Well, if you want to mess around with this, you could do that. What this is saying is, with this data set, comma, we're going to do the mean of this. Well, it's the same. Then you can do this. You have this $ here. We don't need to deal with that necessarily, but that's very common in our language. So what that really says is, we're going to take the mean of the data set, help RCT, with the variable CESD. So to the right of that $ is the variable, to the left of it is the data set. That's probably more important. You'll see this quite a bit, actually. Left data set, right variable, right? So and you'll see that this is the exact same format. They're doing this to contrast this with what they call their formula notation. It might be more intuitive, actually, right? Because this is sort of like an inversion. It's like Yoda, right? Try, there is no try, whatever Yoda says, I can't think of it, but he does kind of a linguistic inversion. This is sort of like a version of that. To the store, the boy goes. Or the boy goes to the store. That's what this with kind of thing does right here. It's saying, okay, we're going to collect our data set with this. We'll do the mean. I'm going to warn you, though, or just apprise you of this. That code on line 4, the mean, the average here, that notation, that $ notation, probably the most common. And probably the least, for me, I think, I would say it's probably the least intuitive for people who are not R aficionados, right? But it's going to be quite common. So I believe we did this last week with the Titanic data set. We can actually do this. We can do the names of the data set here. I thought I need to evaluate that. I'm going to click at the, if you notice, I have right at the end of that line my cursor, and I can click run there. Gives me all these names. So technically you can do this. You can do the mean of any of these. I'm not sure what all these variables are, but let's do age. Help RCT $, and look at this. Once I press the $, it actually helps me out a little bit. We'll do age. And then I'll click return. So an average age of 36. Now, of course, you need to know more about the variables, but you'll see that quite often. That's not the notation we use in class, but you will see it. It's important to just be aware of. And if you like it, go ahead. You'll see it a lot in the blogging sphere. So we have the mean. We have the standard deviation. We have the variance, but I want us to go to the second measure here, which is identical. We have the median of our depression scale. We're going back to depression. Median as opposed to mean, right? The mean is the average. You take each value for each participant, each person, each observation, and then you divide. You add that. You divide it by the number of observations. The median is the middle observation. If you have identical middle observations, maybe say two people with the same, well, we don't have to say that, but if you have two middle observations, you take the average of those. But technically speaking, that's not as common as you might think. But just keep in mind median, middle, mean, average. And they're quite distinct. And actually in the development of statistics, this was very controversial. To have an average is actually kind of strange because it doesn't exist. There's no average out there. It's invented. In contrast, the median, the middle observation, exists technically. Well, it'll always exist. What I wanted, so for example, if you took, say, all the students in this class, lined them up by height, from the shortest to the tallest, there will be one person who's in the middle. If it's an odd number of students. If there's an even number of students, you'll have two who are in the middle, and you'll just have to average those heights. So you'll have an average of two, but you can still pin it to two people. Or if there's one, you'll say, okay, this is the middle, this is the middle. You're in the middle. In my stats class, I was pointed out as being the tallest, which was quite embarrassing. This was in graduate school. But I exist. There's no average that exists. And you'll see that that is in fact true because this person has a score that is in a whole integer. Because you're answering questions, you get a score or not. You don't get a partial score there. That's another measure of central tendency. Now, I want to do now standard deviation here, which is the simple SD function. If you notice, I'm just cutting and pasting here. It's very simple. Okay, the standard deviation for depression is 12 something something something. Well, what is a standard deviation? It is standardized. It is also deviation. It's interesting because in French, it's I think éclaté, which actually means distance. I kind of like that word a little bit better. Deviation sounds deviant, but what it really means is you have the central tendency, the average, and then you have that spread. And what is the average distance from the average in the sample? So you have an average score of mental health. On average, what is the average distance from that score? Notice I'm using the word distance, by the way, because we can talk about distances because we're talking about numerical data. Those distances mean something. We can count them. And that's what the standard deviation is. We also talk about variance, and we can use that using the var function. Now, the relationship between variance and standard deviation is important, but the problem that we have with variance is that it is not, because it is not standardized, it is not in the same units as our mean, as our observations. So it doesn't give us an idea of, compared to the average, how far is our spread. Variance is extremely important in statistics, and it's related to standard deviation. How do we know this? Well, take a look at this little function here. If we take, actually, I'll do this right here. If we take our standard deviation, and then I'm going to put a little caret here. This is just a little mathematical notation. Again, you can look at the R tutorials. I'm going to square this, which means I'm going to multiply it by itself. That's what the variance is. So all you're doing is you're actually, the opposite of multiplying something by itself is to take the square roots. So there is a relationship between variance, which is a good measure of spread, but it is not a standardized measure of spread. And we will return to the concept of variance because it is fundamental for understanding things like correlation, anything else that involves variation. which is why we talk about variables, because variables vary. We want to know how they vary, how they covary, what happens if we change the way that they're measured. Do they vary differently? And what can we infer based on the variance? But typically when we're describing statistics, we often have the mean, and we have the median, and then we have the standard deviation. We also have the mode. So, we also have the, someone asked a great question about the difference between spread and variance. And I'll explain that. But before we go there, I do want to point out, I believe they don't include a mode function here. And most of this is not as important. And look, yeah, there is a mode function, but it's not within Mosaic, which is a little strange. But I think one of the reasons is a mode is not that commonly used. I never see it in scientific research. I actually can't remember the last time I've seen a mode outside of this class. But I want to give you a little mnemonic here. Mean, of course, is the average. Median, it kind of sounds like medium. It's right in the middle. I don't know. Or if you think about when you're driving a car, in American English, we have the median. It's the middle of the highway. The mode, M-O-D-E, is the most often observed observation. So you can think mode has the letter O in it. So it's the most common observation. It's what occurs most often. And that's considered a measure of central tendency, even if it's like I don't know, you have a sample of a basketball team, they're going to be taller than average compared to the general population. And there may not be very much variation, but there's still a mode occurring. One of the reasons I think we don't have modes that often is because if you have, I don't know, a GPA that goes to 2 decimal points, it's very unlikely you're going to have another one that's identical to you. So we often talk about, so we do have 3 measures of central tendency that I talked about. And that's where does the data lump around? Then we have 2 measures of spread that we talked about, standard deviation and variance. And to answer the student's question, what is the difference between spread and variance? Well, spread is not a statistical concept. It is an umbrella term to describe variance and standard deviation. Variance and standard deviation are both measures of spread. How far from the average do the data lie? And I'm going to show this with you with a couple of graphical summaries, and we will continue this tomorrow because we're already over our time. But I'll do this with a histogram, which is different than a bar chart, but it will show you the distribution. And if you notice, this is why I encourage you to use the readings, because it'll get you very familiar to R without having to do too much. If you look at the plots pane, we have a graphical summary of that depression score. Keep in mind, we already have some information here. We know what the average was. Well, what was the average again? Well, the advantage of writing script like this or code like this is we can actually just rerun it. So I'm actually going to delete that. Well, we'll keep that. But I'm going to comment that one out. I'm putting a hashtag between that because I want us to use the code with the tildes, the formula notation. So here we have mean, and then we'll just do this just to get the number out here. So we have 32. That's the average. Well, here we have 40 and that here. So somewhere around here is our average. Okay, that pretty much makes sense. That's a good measure of central tendency. If I looked at this and eyeballed this, where would you bet your most scores to lie on the depression score? If you look at the median, which remember is the middle observation, as opposed to the average, let's see where that lies. That's a little bit higher. So it's still right around the same part. It's a little bit higher. So they're a little different. Why do they differ? Because as we talked about in class, the mean is more sensitive to outliers than the median. The famous example is, let's take the average or mean salary of Harvard College dropouts. Mark Zuckerberg dropped out, Bill Gates dropped out. Okay, well, they're gonna, we put them into any average of Harvard College dropouts. They're gonna look, it's gonna look insane because they're gonna be so rich because they're included in the calculation of the average, because we take their trillions of dollars and then add it up with the rest of our money, and we divide by the number of observations, and then we got these two what are called outliers that are giving us an inflated value. And that's why we like to compare the average or mean to the median, because the median is more robust to these outliers because it actually exists in the data. It is not heavily influenced. And what we notice here is that it's because the mean, the average is a little bit lower. It means that there's some with lower scores than those that have higher scores, which means that the spread is not exactly symmetric. It is pretty close because they're both in the same ballpark, but the spread is being pulled a little bit downward. So in contrast to the Bill Gates, Mark Zuckerberg effect, which would have an insanely high average compared to the median, we have a slightly lower average because there are more people reporting a lower score. And when you get used to looking at histograms and evaluating that in the context of statistics, you'll see that this is kind of a little bit longer on this side. You know, if I were building a pyramid, it looks kind of pyramidal. I would say, well, I'm eyeballing this left side right here, it's a little bit longer than this one. This is steeper. It's because these guys are pulling this average down. Okay, this is why graphical summaries are always important. So you notice here that a histogram gives you a good, you know, and here you see it if you want to take a look at that. And we'll talk about a little bit more about what this means in the tomorrow. What is density? It looks like a bar chart, but it isn't. What does this really mean? I just want to point out that this gives you the overall shape of the distribution. It doesn't necessarily tell you what the heights mean, except relative to each other. Everything's relative here. So this thing called density, that's not really meaningful by itself. If you just covered your hand over this graphic and just looked at this y-axis, and if you were to ask me what it means, I'd have no idea. It all depends on where everything is. What matters instead is the overall shape. This is why taking off your glasses and kind of just eyeballing the shape matters. It's also why variance is not useful for descriptive statistics when we want to understand what the distribution of a quantitative variable looks like. We want to know what data look like relative to each other. So we want to know, what does the average look like compared to, in the same units of the standard deviation. And I'll end on the standard deviation, right? So we have that right here. We have sort of I'm going to actually do a little bit of drawing here. I'll apologize in advance with my pretty bad drawing. It's like Khan Academy style. So yeah, this is, like I said, it's about 34. This is about our average. This is our central tendency, right? This is our mean and our median. And then we have about 12 points below and 12 points up. So 12 plus 34, we'll rely on the median. Remember, that's our standard deviation. So that's on average, how far do the people lie in their depression scores from the central tendency. That's about, on average, they're about 12 points away from the center. So that would be a 46. So probably right around here on average. And then you can go a little bit lower, 34, 22. Okay, so here we have kind of 3 lines here, not very well done, but if you kind of again take a look at this, you have our measure of the center, right? This is the central tendency. We have on average, where do they lie? Below the average. On average, where do they lie? Above. So the standard deviation, which I haven't really explicitly told you, is an average both above and below the center, right? Consider it in terms of absolute value. And taken together, when we talk about statistical inference, when we talk about something called the bell curve or the normal curve, we can make assumptions. Actually, by definition, the perfect symmetric bell curve has about 68%, has 68% of its observations within one standard deviation. So if I were to guess, if I were a betting person, which I don't, because it's not that healthy to bet, but I'd say probably about 60% of the sample probably has that depression score right up there. I forgot what the clinical cutoff was for this, but I believe it was I want to say it was 40. So you see a sizable proportion in the depressed category. But I could be totally wrong about that. But here's a clear example of a numerical data set with a graphical representation of a histogram and measures of central tendency and spread using R and the intro, the student's guide to R. And you, again, if you want to go anywhere in this, you can use any of these commands as long as you have the package installed. And I want to take you finally to just to this last page here, exercises and problems 15. What is it, chapter 15? You might want to look at that if you want more examples. And if you want to learn about the data set that's used, go to 14. It's the same data set everywhere. So for those of you who want to learn more about R, who want to use other commands, what you've learned today is you've learned, first of all, how to use the student's guide to R with virtually no difficulty, cutting and pasting and seeing what happens. I think it's pretty fun. But it requires you to have everything in place. We learned about measures of central tendency and spread and how those differ, and why we want to look at both standard deviation and median, and how variance and standard deviation are related. And then we also learned about the importance of looking at the data. All right, I hope that helped both conceptually but also learning R. And I hope that this is also a resource for you to go ahead and try to have fun with it, because all you're doing is cutting and pasting things. That's all I'm doing. Okay, thank you very much. I'll see you tomorrow. We'll do more of this. And we're going to focus more on the graphics, because the histogram is not a bar chart. It has something about density, and it's important to understand what a histogram is. Thank you very much. And if you have any other questions, and especially if you have questions about the problem set, please let me know as well. And we'll bring that up in section. But also keep in mind Wednesday and Thursday, we also have Justin covering those issues, the problem sets. All right, thank you very much. And I'll see you till tomorrow.